Hi, this is day 3 of solving daily Leetcode problems until I get into Google. Today's problem involves multiplying elements from two sorted arrays and finding the kth smallest product. Sounds simple at first, right? But there is a twist. We are given two sorted integer arrays, nums1 and nums2, and we need to find the kth smallest product we can get by multiplying one element from each array. It is important to note that num1 of I into num2 of j, where I and j are valid indices, return the kth smallest out of all such products. The total number of all possible products is nums1.length into nums2.length. Let's understand this with a quick example. Suppose we are given two arrays, nums1 equals to 2, 5 and nums2 equals to 3, 4, and we are told to find the second smallest product. Now we take each element from the first array and multiply it with each element from the second array. So 2 multiplied by 3 is 6, 2 multiplied by 4 is 8, 5 multiplied by 3 is 15 and 5 multiplied by 4 is 20. That gives us all possible products 6, 8, 15, 20. The second smallest product in the list is 8. So therefore it is our answer. Now let's start with brute force. We could take every element from the first array, multiply it with every element from the second array, store all the products, sort them, and then just return the kth smallest one. That works, right? But it is very slow. Because if both arrays are large, say around 50,000 elements, that's 50,000 times 50,000, which is over 2 billion products. It takes too much time and memory. So the approach is not going to work for big inputs. Therefore now come to optimal approach, which is binary search on the answer. Now let's dive into the code for solving the problem efficiently using binary search. We start our function kth smallest product, which takes two sorted arrays nums1 and nums2 and a long integer k. First we set our binary search range from minus 10 to the power 10 to plus 10 to the power 10. That's the minimum and maximum possible products, considering the array values can be as big as 1 lakh in magnitude. Then we run a binary search over this range. In each step, we pick a middle value mid. Now we call our helper function count less equal, which tells us how many products are less than or equal to mid. If the number of such product is less than k, that means mid is too small. So we move to the right half of the search range. Otherwise we move left. Once the loop ends, the left pointer will hold our answer. Now let's write the helper function. This function takes a value x and returns how many products from nums1 and nums2 are less than or equal to x. For every element a in nums1, we do binary search on nums2 based on whether a is positive or negative. If a is non-negative, the products with num2 will be increasing as we move right. So we binary search for the largest index where a nums2 of index is less than equal to x. But if a is negative, then the product with nums2 will be decreasing, so the logic flips. We now binary search for the first index where a nums2 of index is greater than x and subtract from the total length to get how many are less than equal to x. After looping through all elements in nums1, we return the total count of products less than or equal to x. So the entire idea here is, rather than generating all products, we guess the answer using binary search. And for each guess, we count how many products are below it using another binary search inside the helper. This gives us an efficient solution. Now let's quickly talk about the time complexity. The time complexity of this approach is O of n1 times log of n2 times log of the product range. That's because for every element in the first array, we use binary search on the second array. That gives us log of n2. And we do this inside another binary search over the product values, which adds log of the range from minus 10 to the power 10 to plus 10 to the power 10. So overall, it's n1 into log n2 into log max product range, which is efficient enough for large inputs. That's it for today. If you find it helpful, drop a like and follow the journey. See you tomorrow with a new Leetcode problem.